Hello students, welcome to our YouTube channel Experience Tutor. Today we'll discuss class 12 physics chapter 1 electric charge and fields part 2. And here is our welcome message. Before we begin, we have a request. Please subscribe our channel. Please subscribe, like and share our channel with your friends and relatives. Please click on the subscribe button to subscribe us and support us, and also click on the bell icon to get automatic notification whenever a new video is uploaded. Now let us begin the lesson. Our request is not to fast forward the video. Please watch each and every seconds of the video till the end, if you so that you cannot miss anything. We'll try to make the video more attractive and interesting. So be with us till the end of the video. So today we'll study Coulomb's law. So what is Coulomb's law? The electrostatic force of attraction or repulsion between 2 points electric charges is directly proportional to the product of the charges and inversely proportional to the square of the distance between them. And acts along the line joining the two charges. Now, so again, let us repeat it. The electrostatic force of attraction or repulsion between the 2 point charges is directly proportional to the product of charges and inversely proportional to the square of the distance between them, and it acts along the line joining the two charges. Now let us explain this law. So F is directly proportional to Q1 multiplied by Q2. F is inversely proportional to 1 by R square. Now we can write, or F is equal to Q1 Q2 upon R square, or F equal to K Q1 Q2 upon R square, where K is a positive constant of proportionality. Called electrostatic force constant, or constant, or Coulomb constant. In vacuum, the value of K in vacuum the value of K is equal to 1 by 4 pi epsilon naught, where epsilon naught is the permittivity of free space. Now let us see what is the value of K in medium. So this was in vacuum. So in medium, K is equal to 1 by 4 pi epsilon. where epsilon is the absolute electric permittivity of the dielectric medium. The dielectric constant or relative permittivity or specific inductivity specific inductive capacity or dielectric coefficient is given by K is equal to epsilon R is equal to epsilon upon epsilon naught. Therefore, in vacuum, F is equal to 1 by 4 pi epsilon naught Q1 Q2 upon R square. In medium, F is equal to 1 by 4 pi epsilon naught multiplied by epsilon R Q1 Q2 upon R square. Epsilon naught's value is 9 into 10 to the power minus 12 Coulomb square Newton minus 1 meter minus 2. That means Coulomb square per Newton per meter square. So we can write 1 by 4 pi epsilon naught is equal to 9 into 10 to the power 9 Coulomb Newton meter square per Coulomb square. So this value is very important. Please remember this value. In all the numericals of electrostatics, almost all the numericals, we have to use this value. Coulomb's law in vector form. Now we will discuss Coulomb's law in vector form. So you have two figures. In figure A, so this is figure A and this is figure B. In figure A, we can see that R1 and R2 be the position vector of the charge Q1 and Q2 respectively in a Cartesian coordinate system. Let R12 be the unit vector pointing from Q2 to Q1. Therefore, if we write the equation, then we will get let R1 and R2 be the position vectors of charges Q1 and Q2 respectively. Let R12 be the unit vector pointing from Q2 to Q1. Therefore, R12 is equal to R1 minus R2. According to Coulomb's law of force acting on Q1 due to Q2. According to Coulomb's law, force acting on charge Q1 force acting on charge Q1 due to charge Q2 is F12 K Q1 Q2 upon R12 unit vector r12, where where r12 is equal to modulus of r1 minus r2 is the distance between the two charges distance between the two charges and r unit vector r12 is a unit vector is a unit vector of r12 in the direction in the direction from q1 q2 to q1. Therefore, unit vector r12 is equal to r1 minus r2 upon modulus of r1 minus r2. Therefore, force 12 is equal to k q1 q2 upon r1 minus r2 modulus whole square, which is equal to, and also we have to write the value of unit vector r, which is r1 minus r2 upon modulus of r1 modulus of r2. Therefore, f12 is equal to f12 is equal to k q1 q2 r1 minus r2 bracket uh, modulus cube r1 minus r2. The above equation holds for if the no, all the conditions where the charge is positive or negative. If q1 and q2 have same sign, that is either positive or negative, both of them are positive or both of them are negative, then f12 is along r12, which denotes repulsive force. So F12, now before that we have to write if Q1 and Q2 both have the same sign, either positive or negative, then the above equation hold for Q1 for all the charges if Q1 and Q2 both are of same sign or opposite sign. If Q1 and Q2 are of opposite, then F21 is along minus R12, which denotes which denotes the attraction between the opposite charge. Charges. Now, according to Coulomb's law, so according to Coulomb's law, we can again write the expression as F21 KQ1 upon Q2 R21 and again we can write K Q1 Q2 upon modulus R2 minus R1 R2 minus R1, where R2 minus R1 is the distance between the Q1 and Q2. So we can write where R2 minus R1 is equal to where R2 minus R1 is equal to minus R1 minus R2. Thus, we can write, therefore we can write F is equal to minus Ka Q1 Q2 upon R1 minus R2 closed is equal to minus F1 2. Unit of charge. SI unit of charge is Coulomb. It is also denoted by capital C. The CGS unit of Coulomb is stat Coulomb. Or ESU of charge. Now we will define 1 Coulomb. What is 1 Coulomb of charge? So 1 Coulomb of charge is that charge which when placed at rest in vacuum of a distance of 1 meter distance of 1 meter from an equal and from an equal and similar stationary charge. Similar secondary stationary charge. Stationary charge repels it. It and is repelled and is repelled by repelled with a force with a force 9 into 10 to the power 9 Newton. So this is the definition for one coulomb of charge. This is the end of today's topic. Please like, share and subscribe our channel and give a comment on each video. And thank you for watching our videos. Thank you for supporting us.